Often we think of light as photons or quantized packets of light. These photons have an exact energy dependent on their frequency and Planck's constant. Now this photon can do all sorts of things. It can allow us to see it when it hits our eye. It can also eject electrons from metals. So this photon will come in, interact with the electron, and release it so that it can fall out. This is called the photoelectric effect. Notice that the photoelectric effect, which is described mathematically here, depends on the energy of the photon, which just depends on frequency. So if I have really bright red light and really dim red light, the energy of the electron coming out is still going to be the same because the energy binding is constant and we have the same energy of the photon. Instead, this bright light will actually bring more photons in so you can eject more electrons. Now there's also a weird thing about photons that might not be clear. They actually have momentum. Typically we think of momentum as mass times velocity, but for light, E equals PV, where P is the momentum. You can rearrange this using the relationship between wavelength, frequency, and V to show that the momentum for light is just equal to Planck's constant divided by lambda. As it turns out, this relationship is true for all objects. So de Broglie actually proved that if this is the case, we could plug in mv for momenta of any object and get the de Broglie wavelength of that function. So if I'm running down the street with some velocity and I have a mass, I know exactly what my wavelength would be, so I'm actually oscillating up and down. This is referred to as the particle-wave duality because we're definitely particles, but we also now have a wavelength and a frequency.